Hello, everyone. Thanks for being here this afternoon. My name is Shrikant Deshpande. I'm the product manager on the RDS team. You have a bunch of sessions that you could go to, but I'm really thankful that you're here. Thanks for your time. In the past few years, we've seen Postgres take off very well. You have built mobile applications on top of Postgres. You've leveraged the geospatial abilities to build application software using Postgres. Using the enterprise abilities of Postgres, you've built great web applications. With the challenge, the power, the complexities, and the performance of Postgres do come the hassles of managing these databases. As you heard in the keynote this morning, Werner announced that we're supporting Postgres on RDS. I'm really excited to be here to take that undifferentiated heavy lifting of managing your databases off your hands. We're really excited to offer Postgres as a managed database service on RDS. I know we are probably one of the last sessions standing between, and we're probably standing between you and the socials this evening. Just want to make sure, I assure you, that you'll have a really good time here and hopefully get all your questions answered. My partner and software dev manager, Nick Hurdle, will walk you through RDS Postgres. At AWS, all of our stories begin with the customer. We're very fortunate to have one of our very early customers, Moody's Analytics, and Gabe from Moody's, who's going to share their story around Postgres and their very early experiences with RDS Postgres and their vision for RDS Postgres and their use cases around it. Without much further ado, please welcome Nick Hurdle.
Thank you. Hi, everybody. My name is Nick, as he said. I'm a dev manager with the Relational Database Service at Amazon. I'm really excited to be here to talk about Postgres with you. When we first started in 2009, we started with a focus on having a choice of database engines. We began with MySQL. We later added Oracle, and then also Microsoft SQL Server. And I'd like to introduce you all to the big blue elephant. Each of these engines is managed as part of RDS. It's easy to scale, easy to operate, high performance, high availability, all these things that you're already potentially used to from your usage of the MySQL, Oracle, and SQL Server already. You can now do that on Postgres as well. So a logical place to get started here is how to launch your first instance, how to get your data imported. And we'll get there. But I do want to start with some of the more fundamental pieces of RDS, just for those that may not be familiar with the whole story. RDS provides a couple different ways to manage your backups. You can take a DB snapshot manually at any time, which is then stored and can be restored to later. You also have the opportunity to turn on automated backups, which will actually schedule daily snapshots, much like the automated ones, but you don't have to worry about calling the API. We take the wall logs, the transaction logs from Postgres, and we'll upload them and save them every 5 minutes. And it enables you to restore to any point in time throughout that restorable time period, except for, of course, the last several minutes where the most recent logs may not yet be available. Great thing about this is if one of your developers accidentally deletes a whole bunch of things without a where clause on their statement, or maybe they accidentally drop a table, or some other unforeseen problem, it's not a problem. All you have to do is call the restore DB instance to point in time API, and you're back up and running. Now, we also recently announced something called cross-region snapshot copy, which allows you to take any one of these snapshots and actually transfer it to a different region from which you took the snapshot. It's great for either moving your data to a different region when you're switching locales, or for disaster recovery. We've had a lot of customers talking about wanting to have a backup plan. If there's some kind of a long-term, region-wide disaster scenario, you'd be able to restore from this snapshot that you took in one region in another region. Now, the next big thing to talk about is handling scaling. A couple different kinds of scaling, starting with the compute nodes. Most businesses, when they start off with their first database, they're happy with the smallest, cheapest option, which in our case here is the micro, which is available on the free tier. As things grow, you want the opportunity to have your database grow with you. And we support a whole slew of pre-configured options, from small all the way up to the 8x large. On the storage side of scaling, you can start with as few as 5 gigabytes, and then incrementally add more as needed, up to 3 terabytes. We also support the provisioned IOPS, up to 30,000 provisioned IOPS, which provides not only lower latency, faster response time, but also more consistent. Now, if you configure the biggest, baddest instance you can, 8x large, 3 terabytes, 30,000 IOPS, and it still doesn't really do the task that you need it to do, that's when horizontal scaling can come in. This is a little bit more of a complex topic, but the key message here is that RDS provides really fast provisioning. So as many as you need, they can be easily created using the RDS APIs. Now, the next thing to talk about is your availability. Many of you are probably familiar with the multiple regions. Within each region, there are multiple availability zones. And the multi-AZ deployments is the RDS approach to providing a fault-tolerant, highly available deployment model. You'll have your primary node in one of those zones, your secondary node in another zone. Your application will connect to the primary node by using a CNAME DNS record that we provide. And then if something happens to the primary node or the primary availability zone, it will be automatically failed over to the other zone. And your application will be using that new node without needing to reconfigure your application, without needing to be paged in the middle of the night to wake up and fix it. RDS will handle that for you. So digging in a little bit to how to set things up securely. When you first create your database, you'll be providing a master username and a master password. That username will be the most powerful user on your database. And the naive configuration is just to use that user for your application, because it's easy. But we highly recommend setting up a lower privileged user that has just the minimum permissions necessary to get the needs of your application accomplished. This will limit the blast radius if there were some kind of a problem and that user was compromised. The next layer of security to think about is network. We provide a couple of layers there. First is database security groups and VPC security groups, where you can use these things to limit the number of external nodes that have access to your database node. You can specify either CIDR ranges or EC2 security groups. Now, going even deeper than that on the network layer, we provide something called virtual private cloud, which allows you to actually put your database node in a private subnet, where the outside world, the larger internet, doesn't even have the ability to resolve that address. Your application, of course, would be in a public subnet or with public IP addresses that allows for your customers to access the application, but it adds additional security to the database layer. Now, each of these configurations is manipulated using your AWS account, that email address and password that you use to log into the AWS console and make these changes. It's a pretty powerful set of credentials. We do recommend using the identity and access management to configure lower privileged account management credential sets that you can either hand out to others in your organization or use yourself to, again, limit the blast radius if any of those credentials did end up getting into the wrong hands. Now, getting into the actual creation story here, when you're ready to create your first Postgres instance, one thing to think about is what parameters is it going to use? Now, since RDS is a managed database service and we don't allow direct connection to the file system and manipulation of the configuration files, we have a thing called a database parameter group. And you can set up the same groups that you're already familiar with in these, the same parameters you're familiar with in these groups. And you can see here I've actually filtered, for this demonstration purposes, there's about 150 parameters, and we're just showing a few of them that include the word connection. The first couple are actually engine default parameters, where RDS isn't really doing any override. It's just going to use the same value that you would get if you installed Postgres and didn't set the parameter. The one right below it has a source of type system, and you can actually see there's a 1 in that text box there. That shows that RDS is providing a value. It's overriding the default that Postgres would provide. And then that fourth one there is a little bit more complicated. It's using a formula to come up with the actual parameter value. It's taking the DB instance class memory, and it's doing some division so that if you use this parameter group on a micro or an 8XL, the result will be different. It allows you to use the same parameter group across a whole set of instances, and it even allows you to scale one instance in a parameter group without needing to continuously rejigger those parameters. The other thing to note here is that the top 3 parameters have apply type dynamic, and the bottom 3 have apply type static. Static just means that they're parameters that need to be set in the actual config file, and the database software needs to be reloaded. So when you apply those changes, the only way to do it will be pending reboot, and then you'll need to call the reboot DB instance API. The dynamic ones are a little bit more flexible, where you're able to apply them immediately, and they won't require a reboot. Now, everything I've talked about so far, including the parameter slide just there, is available for all of the engines. Except, of course, for the parameters, it'll be a different set of parameters per engine. Now, for Postgres, the initial offering will be 9.3.1, and everything you've heard so far will work for that version. Now, when you get into the actual creation wizard, if you've seen the screen before just without the Postgres option, that's the standard database creation wizard. And you'll click the select button next to the Postgres. This screen is where you choose whether it's a production database or not. This is really just a simplification of some of the defaults. If you're using the command line tools instead of the web wizard, there's no option for this. It just has an impact on defaults. So here's the first place. The 3 on the bottom are never provided with a default. You'll always be selecting your own DB instance identifier, your own master username, and your own master password. Those are the 3 big ones that you'll want to think carefully about what you put in there and remember them. Now, the next screen, when you do additional configuration, you'll see there's a parameter group option. The default parameter group is, of course, titled default, Postgres 9.3. If you did create a custom group and you put any special parameters in there, that dropdown would, of course, include those custom groups that you created. Now, on the next screen, this is where you'll be selecting the backup options. I talked earlier about automated backup retention, automated backups, the ability to do a point-in-time restoration of the instance. This is where you'll want to make sure to include automated backups, yes, and select the appropriate backup retention period for your needs. Now, once this is all created and it's gone through the whole creation process, you can view the details of what you've done. And there's a lot of information on here. The really important bits, though, are the endpoint and the port and the username. I've actually shown a little smaller version here with arrows to show how you'll actually put that into your client UI. This is just a screenshot of the Windows PG admin utility. But of course, any other utility would work as well. For example, PSQL or anything else you're familiar with. The host would be the name that you provided with the rest of the stuff included in the endpoint there in the UI. The port default is 5432 and can be overridden. The username is the master user that you created. And of course, once you've logged in initially and created a lower privileged user, you would then be able to use any other user that you also created. And then the password isn't stored anywhere on the UI. That's one that you'll need to remember. But of course, if you do forget it, there is a modify DB instance API, which if you do have the account credentials for the AWS account, you'll be able to reset the password to recover access to your instance. Another reason to use identity access management. So to talk a little bit more about how the permissions are handled, I said earlier that RDS is a managed service. And when we say managed, it means that there's certain things that you don't have to worry about. And RDS manages for you. And in order for that to really be possible, we don't give the full super user role to that master user. That super user role, we added to it the RDS super user role. And the RDS super user is a role provided to the master user that you initially created. And with those permissions, you can do things like load and use extensions. You can view and kill sessions for other users. You can create and manage table spaces. You can assign the replication role. A couple other things that aren't listed on here. But the core idea is that these things should work in the same way as they work on your existing instance. No need for special stored procedures or anything different than you're already used to. The same syntax will just work. And the RDS super user role should be managed just like the super user role that you're used to. So I talked about extensions, loading and using extensions. I'm happy to tell you that the PostGIS extension is included. There's a whole slew of additional extensions on this slide here. There will be a quiz at the end, so please remember them all. I'm kidding, actually. There's the RDS extensions parameter available from within your Postgres database or on the RDS APIs. That parameter will always display the full comma-separated list of available extensions. You'll note that there's a couple in there around language support, a couple around handling geocode data, and some of the other most popular ones that you are likely used to. Now, we've also done some performance analysis of how Postgres behaves within the AWS cloud. We set up the most beefy instance we have with the 8x large. We attached the full amount of storage, the full amount of provisioned IOPS. We ran a pretty straightforward I/O load test on it. You can see the results here via the CloudWatch graphs. These are the exact same graphs available to you when you use RDS. And you see that we were able to achieve over 25,000 IOPS in total. So when you leave here today and you want to go launch your own Postgres instance, a couple things to think about. You go to the console. You'll launch the instance. You'll need to configure the network appropriately. We talked a little bit about network security. Make sure that you get the network settings appropriate for your needs. Think about the parameters, which we talked about earlier as well. If you have extensions that you're already using, make sure that those are included. Get those loaded up into the database that you're planning on loading. And then you can use the PG dump utility on your existing databases, if you have them, to export your data. And then PG restore to import into your new RDS database. If you have any questions when you're getting ramped up on this, you can feel free to contact RDS or Srikanth, who will have some pointers there. We also have a forum available for posting questions. We have some support opportunities as well. And with all that said, I would like to introduce Gabriel-Arnett from Moody's to tell us a little bit about how they're using Postgres, how they're using AWS, and give you a little bit of a preview as to what you can expect.
That one?
Forward.
OK. Thanks, everybody. It's really exciting to be here, and we thank Amazon for giving us this opportunity. We're also really fortunate to have gotten the early access to this offering, and I'm happy to share with you a little bit of our Postgres story. It's a little bit exciting for us, at least. So with that said, I got a minute. There we go. So who exactly is Moody's Analytics? Moody's Analytics is a subsidiary of Moody's Corporation. You may know well Moody's Investor Services, which is a global ratings business. We are a conglomeration of several other entities that Moody's Corporation has acquired over the last decade. And we basically bring to fold latest, greatest, best of breed research analytics tools. We have advisory services, we have software, and really a lot of opinion-based things that help the marketplace get the feel in the Moody's product itself and to manage their own risk financially. So what do we have today? The one use case that we have that I can talk about is a project that near and dear to those of us in our team. We are rebuilding a legacy problem. As you can see on the screen here, I've got Sybase, I've got Oracle, I've got SQL Server, and I have a glorious 12-year-old calculation engine that was produced in MATLAB, converted to C++, and wrapped with Java. It works well. I won't lie. It does what it needs to do. Is it time to rebuild it? Absolutely. So I know right now you're all getting hungry. I figured I'd tease you up, let your appetites get a nice digest here. I think you're all going to run out and have some spaghetti later. Happy to look at this slide offline so you can see these details to see how fun of a mess we're undoing here. We have lots of external data sources that are different structures, different formats, different timelines, all relatively the same sort of financial data that we're pulling in. We have various application layers that transform that, persist it into stores using Sybase, SQL, and Oracle. We also then run it through the various calculation flavors and the different C++ DLLs, and then we output that result again into a bunch of fun replicated Sybase servers that are fronted by a web application. So what am I going to do with that? I'm not going to get into a lot of the details around the calculation and around the loading, but the data layer we're going to convert, shift it all in. We're going to use Postgres. Happy to talk offline with anybody about why we're doing this, but I love elephants, so let's just say that. So what did we really do this summer? And I say summer, it was really a combination. Obviously, we have a lot of other projects and tasks on our hand. For the most part, it was a lot of learning for us. Postgres isn't new to me. It is new to some of the people on my team. Some of the technologies are different with the latest versions of Postgres. Some of the capabilities are pretty glorious, in my opinion. Pretty great for a free open source product. So with that said, we really played around with how do we build this data warehouse using this? How do we look at this whole scale as an enterprise? How do I do the fault tolerance and the resiliency and check my little box off for all the BCP types that need to know that if anything happens, that it fails, I can back it up. Also, architecturally, what do I do to sort of lessen the load and shift that load for the application layer so it's even faster than it is today? With that said, we basically created a single write master. We had a secondary standby that was warm that I didn't really have anything reading or writing to other than the write master using wall. We did some cascading replication. My first instance, I went crazy. I had like 6 read replicas thinking, why not? Good learning opportunity. We did it. Was it as fast and real read time as we imagined? Not so much, but thankfully I don't need that problem. So with that said, the calculation engine is being rewritten using another proprietary statistical packages that are open and fun and lightweight. Those are basically reading from the read replica, and they're writing back to the write master. We load the data in using our ETL cluster that is processing the raw formatted data, loading it into the write master, doing more transformations, getting it prepped for the calculation, and then storing that as an archive into S3. Give or take a few hours here and there over the course of a couple months, that's what we did. So what were the pros of this? Obviously, we learned a heck of a lot. We could probably write a decent blog post, maybe a white paper here and there. We didn't really have any cost other than time and infrastructure. And on Amazon, the infrastructure for us as a big enterprise, the cost really wasn't a factor. Thankfully, those guys at Amazon are doing a fabulous job of helping us prove a silly point of nothing costs any money anymore. That being said, support maintenance tasks were very reasonable given the open source nature of this. It's easy to learn, it's easy to get up and running. I can use my existing resources to do these things. It wasn't a stretch to, sort of influence and jazz up and get my development staff motivated to do this. It is open source, everybody wants to do that. And it's an elephant. So obviously everything isn't glorious. There are cons to everything. Obviously lots of time. We spent a lot of time testing. We spent a lot of time configuring, trying to find that sweet spot. And I'll be honest with you, we're still trying to find some sweet spots. Thankfully, I'm in an agile dev cycle, but I have some time to get this done. I have a calculation quant team that's taking their time redoing that part. We're thankfully right now in parallel mode, so we can do a lot of this together and figure this out and say, where's your sweet spot? Where's our sweet spot? So there's a little bit of that. It does take away time. Some valuable development time. We could be doing other things, but we like doing this. It's fun. I have to, like I said, convince really talented Java, Python, .NET developers that they also have to maybe become Postgres admins. Is that fun? Maybe. It's part of the job. I can make it a part of their performance review, what have you. That being said, we're an enterprise. I have people above me that really need me to check off those boxes and guarantee that I can support this. It's a bit of a struggle to tell my developers, no, it's okay. When we're in production, if I call you in the middle of the night, we'll step up. But we could pay other companies that are out there that provide this level of support that give us this nice to have. But for the most part, I think we're all really comfortable, and we're not going to get woken up in the middle of the night because we're all going to change our phone numbers. So that being said, what did we do when we found out that Postgres was finally going to be offered through RDS? Initial thoughts were, wow, that's great. Why didn't you tell me this 5 months ago? You've told me other things before. You could have saved us time. But in hindsight, like I said, it was a great learning opportunity. Should we somehow not be allowed to do this or it doesn't net out, we now know how to do it ourselves. Do we really want to do that? No. I think somebody alluded the other day in the keynote, the value add is this frees developers up to develop. You don't have a dependency on infrastructure. You don't have to be a sysadmin. You don't have to know how to RAID. You don't have to know how to do these things. I'm guessing, I'm old enough that I would love for these developers to learn this stuff and be well-rounded, but one day we'll have developers that, I only know how to do this one thing. I don't have any idea how to do this anymore because Amazon's doing it for me. So that being said, we have a single write master still, multi-AZ out of the box with a checkbox. It's kind of nice. A warm standby, obviously. The couple weeks ago or 3 weeks ago, I believe, the snapshot copy across region, pretty impressive. I could check off my little DR box. I don't have to worry about that. I can tell my boss and his boss, no, we're covered. Don't ask me the lossless factor, but we're covered. Everything else stays the same. I think in the future, obviously, we will probably come to suspect, or I guess, hopefully, get the read replica capabilities that are out of the box with RDS other packages, which allow me to then plug and play my same infrastructure without a lot of heartache. That being said, self-explanatory here. I think it's sort of no-brainer, and I'll go into some of the specifics. So why? Why not? Achieve the same performance. In fact, we're seeing better performance than the glorious stuff that I thought was great, and I had finally harnessed and said, woohoo, I can now get near faster disk performance than physical. Don't ask me how I came to that because it was a stumble and trial and error. Several nights I sat there going, wait a minute, what did I spin up with this volume? Did I attach it right? Did I mount it right? Is the RAID correct? Some of my team can attest that I went in, they were like, what's wrong with you? You needed to get some sleep. We get built-in backup recovery, fault tolerance, all of those things that can be a challenge, right? Especially on our own. Obviously, your disk is only going to be as fast as your slowest one. I don't have to worry about that. I don't have to care about it anymore. I think one of the sessions I went to previous to EBS and optimizing, there were several questions asked. Well, in the RDS thing, do I have to worry about this? Do I have to do this? No. Easy answer. So that's really a gangbusters. There's more operational support around that. The RDS team, it's on you guys. It's not on me anymore. I can pick up the phone. I can blame you. And we will, whether it's your fault or not. So, sort of the difference of up and running for our perspective. What was it like? I think Nick showed you sort of the steps that you would take offline for what this is. And a lot of this, we sort of figured out on our own. It's Amazon. It's easy. It's not hard, not rocket science, although all that's behind the scenes. So on our own, obviously, we had to launch EC2s. We had to figure out which instance size was right. We had to figure out the EBS portion. We had to then mount it. We had to rate it. And then we had to hope and pray. Then we installed Postgres. Then we moved the data and the logs around because nobody wants to keep it in the same spot that it is default-wise. Then you edit your configuration files for all of those different parameters that we thought we needed, like connections and your buffers and everything else. And you had to do a fun bit of math and trying to figure that out. And which is the sweet spot, who knows? But somehow we managed to stumble upon it. Then you create your users, you load the data, you use the data, and then you create a snapshot, and then you hope maybe that you remember to create it every now and then. Thankfully, I'm not in production yet, so not one of those things that I had to worry about. Did have a failure on our own. I lost it, I had to reload it. Took about 2 weeks. Not so fun. So with RDS, obviously, your PGHBA, the security settings of who can hit it, always a fun challenge, especially for us and our network infrastructure and our challenge. I have no idea what our NATed IP is for our various offices throughout the world. I had users hitting it. I had to make them go to what's my IP to tell me what their IP was, then go in there, edit the file, restart Postgres, hope it came back, and then have them test again. Obviously, there's 12 to 24-hour difference between that test period, so it wasn't a lot of fun. With this, it's out of the box. The best part is you can change and add it on the fly. You don't have to restart anything, and voila, people are up and running. The parameter group, that's your configuration file. It's out of the box. There's a little bit of challenge around that math to tweak it to be, and quite frankly, it's actually a lot smarter that way than me coming up with my own terminologies. I think the PG210 is out there. There's some pretty good tools that have been built for the days that help you get there. But then, you don't ever want to rely on somebody else's logic. So then you launch your instance, you load the database, you use the database, you sit back and watch it. One of the valuable adds is the CloudWatch built-in capabilities for us. I don't have to go into CloudWatch. I don't have to sit there and remember which instances. I mean, for the most part, I have 2 windows open, and I go back and forth and say, what's this instance? I go find it, I click it, go back, click the other checkbox for CPU, and trying to get it all in one place. All the valuable things up front that you need are right there. And that's gangbusters. So thank you guys for that. And that's really it for us. I think some of the other bits, the backup retention that I talked about, that point in time, I mean, that's just truly awesome. I mean, I hadn't even wrapped my head around how I would do this on my own. Thankfully, now I don't have to. I think the snapshots are very easy to find. The schedule is set up. In fact, I didn't even really realize it because I clicked through the screen so fast the first time, and then I went back and I was like, oh, wait, look at that. I don't even have to do it. It's done. Check, done, good. Do something else. It's all single click, very fast. I think it was give or take about 4 or 5 minutes I was up and running. That's gangbusters, really. So monitoring, like I said, you have it all right in one place. The logs are there. I think one of the fun capabilities, and we hadn't really used RDS as a service itself. So, whether that's been there all along or not, to me it was huge. I was like, look at this, you can tail it, and it auto-refreshes, and I can see what's going on. And that really helped us because some of the calculation engines, we were running and playing, and he would kick off a big query, complex query, and he's kind of mellow and let it run, and it would go for a couple hours, and then he'd scratch his head and be like, hey man, there's things still running, what's going on? What do you mean it's still running, right? Go in there and look, I can see what's going on, there's retention, there's changes. We can change things up pretty quickly, get going, and finally it was a lot faster and it was a lot easier to have that right in my face rather than going in, SSHing in and trying to figure out which log to read, how to parse it, what line, where. Very challenging. And then on top of that, say something does go wrong. I have event subscriptions for faults and everything else out of the box right there. If I have a problem that I think is common and is important, I can schedule it, set it up, call it a day. That helps me be a lot more proactive than reactive. Outside of that, scale and redundancy, obviously the multi-AZ with a click, pretty cool. In our bit, we had to spin that up. We had to configure WAL. We had to see if it was working. We had to test it. We had to bang away on it. Some of that was fun. Some of it not so fun. Some of it, we damaged our own instances, had to wipe them out and rebuild them. So it was a little bit of a trial there. Lossless factor is a huge risk of the fail. We did enough testing for me to be comfortable, and then I stopped. Luckily for this use case, it's a very scheduled transaction, so we don't have that big of a deal where if I know in this time period something failed, I know when I've got to replay to. I know where I'm dealing with. So beautiful thing there. Great for our use case. So what are we going to do next? Obviously, we're going to add everything in our platform to Postgres. Just kidding. We are going to access a lot of our other legacy projects that we're doing, and nothing nearly as fun as sexy as the one that I showed you, but similar problems in nature. You can imagine as a financial firm, we have a lot of Sybase, we have a lot of Oracle. So there's a bit of a challenge there to move these platforms over and create various data marts, spin up a proper SOA layer, do all those fun things. So other things that we're doing with Postgres, we're sort of playing around with the JSON data type right now, making it NoSQL-like. It's pretty fun. It's pretty powerful. A lot less development. Easy read-write compatibilities. We're integrating that with Solr. We're going to stretch and push this into our front-end data marts where we can. Although, I might have to suffer through a lot of rotten fruit and vegetables thrown at me from my .NET guys who swear by SQL Server. And then we venture back and sort of use Redshift in that capability. And as you all know, Redshift is sort of founded on the Postgres-like mentalities. Then go back to our business and analytics users and say, hey, so all that $20, $30 million worth of data vendors we get, and we pull in all those sources, and you really only use 1%? Here's a value add for you, and here's a mechanism for you to spin this up and look at it and say, hey, look, maybe we should use the other 90%. We can derive a new product out of it and see what it does. With that being said, I'd like to welcome Nick back up. Thank you for the time. Thank you for letting me share our story, and happy to talk offline to anybody. And I think Nick will come back up and help you guys answer some questions, and I'll answer anything you got now.